Hello everyone, and welcome to our video on higher order derivatives. So a derivative is a function, and if we have a function, we could take a derivative of that. So once we take a derivative, we can keep taking derivatives. Now it gets usually a little abstract after the second derivative, but they still represent rates of changes. So it'd be like a rate of change of a rate of change. Okay, so it gets a little strange. So we'll see applications on that a little bit down the road, but right now we're just going to break down how to do them. So there's different forms. We have let's write it like this. I'm going to try to space it out. So here's our original functions, and then we have our first derivative. Usually the notation, if we start with y, would be dy dx. If we start with f of x, it's usually f prime of x. Our second derivative, so if we keep going with our second derivative, we get this notation d2y dx2, where those look like powers, but they really aren't powers. It's just telling you you're doing your second derivative. And where that comes from is this notation saying, hey, we're about to do the derivative of a derivative. And then they do almost treat it like powers. Okay, they aren't powers. It's a little confusing, but it's kind of like saying this d and that d multiplied to get d squared, and then this dx and this dx multiplied to get dx squared. It's kind of like that, but again, these really aren't powers. Okay, so it is just saying that is the second derivative. And then our f notation is a little bit more clear. It's just put another prime on it, so f double prime of x. And then it keeps going. So the third derivative would be d3y dx3, and then f triple prime. And then let's get two more. I think we can squeeze them in there. Our fourth derivative would be, well, d4y dx4. And then at this point, they usually don't put primes anymore. They usually do parentheses and then whatever number derivative it is. So f and then that little 4, again, they put parentheses to make sure, again, we know, hey, it's not a power, it is a derivative. Okay, and then it goes in this pattern forever. And so what we would say is the nth derivative would be dny dxn, and then dot dot dot, let me put the dot 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 f whatever the n is of x. So it was like the 20th derivative, those little n's would become 20 for each case. Okay, so those are the notations, or at least the main two notations. So let's see this in action. So we're going to find the second derivative of these problems. All right, so just like any derivative, we want it in the correct form. So before we do anything, this one should be rewritten. Oops, I don't really want those parentheses. This one should be written as x to the 1/4. Okay, so remember the fourth root is the same as x to the 1/4. And then this is just the power rule. So I'm going to do the derivative, first derivative. Let's do the dy dx notation by bringing the power to the front and then minusing 1 from the power. So if we need scratch work, again, that's fine. That would be -3/4. Okay, so if you don't need scratch work, that's also fine. Okay, so there's our power there. And then what we're doing now is doing another derivative. Okay, because this is its own function. So let's do another derivative. So d2y dx2. And then still it's the power rule. So that 1/4 is just hanging out. And then the -3/4 would come down and multiply. And then we need to minus 1 from the power. Again, just a little bit of scratch work. 3/4 minus 1, or 4/4, would be -7/4. So that should be the new power there. Okay, and so that is the second derivative in green. I'm just going to clean it up. I'm changing it back to black ink. So it is now just simplify. It looks like it's -3/16 x to the -7/4. There we go. Okay, and if they force us to change it, we can change it back to a square root if we need to. I'm going to box that though because I'm out of room. And usually we're fine with this notation. All right, so number 2, here we've got a chain rule problem to use. Okay, so you can break these down into words, or you could do it in different ways, but if we're doing the chain rule, we would say, well, this here should be u. Okay, so I'm going to use blue. So u is 4x squared plus 5. And then if you like u prime or if you like du dx, choose which one. I'm going to do du dx for this problem, which is 8x. Okay, so there's our derivative with respect to x. All right, so now we can set up our chain rule. So we have y equals u cubed. Okay, we haven't done anything yet, but now let's do the derivative with respect to x. So dy dx. Oops, let's do it in blue. I'm just going to highlight over. So that's showing we're doing our derivative. Dy dx is 3u squared, and then times the derivative of u with respect to x. Okay, and so we can plug those in. So we get dy dx equals 3, and then u is 4x squared plus 5, and then du dx is 8x. Okay, so there's our, oh, I forgot the square almost. There we go. Okay, so we subbed in the u and we subbed in the du dx, so it looks just like that. And then, well, we should multiply the 8 and the 3. And then I'm also going to put the x first, or with it at least. So 24x, and then 4x squared plus 5 squared. All right, there we go. Now we need to do the derivative again. Okay, so our second derivative, well, this is a product rule and a chain rule problem now. Okay, so we've got that 24 is just hanging out. Remember, we just write it like that. But here we do have whichever notation we want to use. Let's do F and let's do G. So sometimes I do U and V. I'm going to do F and G here. Okay, so that means our second derivative, our d2y dx2, again, the 24 is just hanging out. And then I'm setting up the product rule. So I know it's f prime g plus fg prime. And then we'll sub those in. Okay, so let's put this up here now. So we've got d2y dx2. Again, 24 is just hanging out. Okay, so the f prime, the derivative of x would be 1. Okay, that one's a good one. And then g, we just write in. So that's 4x squared plus 5 squared. And then plus f is just x. Okay, so there's our x. And then g prime. Okay, so the g prime part. So it is the chain rule problem again. It's u equals 4x squared plus 5 again. And then our du would still be, our du dx is still 8x. So it matches similar to before. The only difference is that it's a different power. It's 2. So our derivative would look very much like this first one. I'm just trying to save a little space. So instead of 3 though, the 2 comes down. Okay, so we've got, let me actually erase a little bit. I think I can squeeze that in if I just move it a little bit. Okay, so sorry, that's plus x. Okay, so when doing the derivative of g, we're saying the 2 comes to the front, so 2. And then 4x squared plus 5. Oop, a little off. And then that would now be to the first power, so I don't need to show that. But then times the derivative of 8x. Okay, so I did run out of room. I'm just going to squeeze it down below. Okay, and then now we're just going to clean this up. So I've got d2y dx2, the 24 bracket. 1 times the 4x squared plus 5 squared would just be 4x squared plus 5 squared still. And then plus, on the right side of the plus sign, we do have a 2 and an 8. That would become 16. We also have an x and an x, which would become x squared. So we have plus 16x squared, and then in parentheses, the 4x squared plus 5, and then a bracket. Okay, so that's our derivative, our second derivative. And then however way we would want to simplify it from here, they might FOIL out the 4x squared plus 5, and then distribute. What I'm going to do, let me underline. Okay, so now I'm just simplifying. These are in common, and they're each to the first power. So let's take that out. So let's write it as, so d2y dx2, the 24, and then we're saying, oh, 4x squared plus 5 is common in both. So I'm taking that out, and then let's set up our bracket again. So inside the bracket, so I took 4x squared plus 5 out of this first term. It was squared, so that means it's no longer squared, it's just 4x squared plus 5. And then in the second term, I took it all out. I took that whole 4x squared plus 5 out. So I'm left with plus 16x squared. And then we'll finish it off. The 4x squared plus 16x squared would combine in there. So our final answer would be, so d2y dx2 is 24, 4x squared plus 5, and then 20x squared plus 5. So 16 plus 4, like that. Okay. And then after that, you could factor a little bit more with a constant, I see, but I think this is good. Okay, so that's how we can break that one down. Okay, so that was a chain rule problem, and then it turned into a product rule problem. Okay, so the second derivatives, they can get harder as you go, depending on what the original function is. Okay, but take your time, break it down. Okay, so thanks for watching. If you have any questions, please let me know.